With these identities, we can even do, I'm sorry, start over. With these sign of the sum and sign of the difference identities, we can also do verifying another type of identity. In other words, take these signs of sums and difference and create a formula based on tangent, or vice versa, take this formula based on tangent and convert it into the sign of the difference of the angles over the sign of the sum of the angles. Usually when I do a problem like this, I like going with the uglier side, and in this case, the uglier side is this. But it actually turns out that working with this side is easier, but I'm not going to. So I'm going to go with the more difficult side. So I need to know what the identity for the sine of a minus b is. So that is sine of the first angle, cosine of the second angle, sine being minus on the inside, it's minus on the outside, sine of the second angle, and then cosine of the first angle. Switch the order of the angles. All over, and then this is just the sum of them, so it's going to look very similar, except in between is going to be a plus. Oops. And we get that. Alright, so once I break these two down into their separated form, so I get away from the sum and difference of the angles and I just get sines and cosines of angles, my goal is tangent for all of these. And the only identity I know for tangent is sine over cosine. Sine over cosine is what is equal to tangent. So what I need to create here in this first spot is tangent A. So that would be sine of A over cosine of A. Now you can't go stealing things from down below because of these minuses and pluses. So we're going to pull another trick. We're going to go through and divide by cosine A right here in this position. And when I do that, I'll get tangent of A. And over here, if I divide by cosine of B, this becomes 1, and all that I'm left with is tangent of A. So let's see how that's going to work. I'll just draw a fraction here. I'll leave the denominator blank for now. And the general rule with fractions is whatever you do to the top, you do to the bottom. So I need to do everything exactly the same. In other words, each one of these things I have to divide by the exact same thing. Alright, so sine A, cosine B, all divided by something. And then here plus sine of B, cosine of A. Oops. All divided by something. And I think that something is what forces this first one to become tangent of A. And it forces the second piece just to become 1. So this part will give me tan A, which is right there. If I do the same thing here, it has to be exactly the same. Cosine A, cosine B. These two will give me tangent B. These two will cancel out. So it gives me tangent B in the second spot. So it seems to be working. Cosine A, cosine B, and cosine A, cosine B. Divide everybody by it, which is totally legal because you're doing it both to the top and to the entire bottom. So here again, you're going to get tan A. Here again, you're going to cancel those two out. Here you're going to have tan B, and these two are going to cancel out. So I'll get rid of those, get rid of those, get rid of those, and get rid of these. So my final result is literally tan A from these two, tan B from sine of B over cosine of B, all over tan A again, plus, and then these two, tan B. And we end up with the exact same thing that we're looking for.